In order to graph a rational function, these are the steps. First, factor completely so we can check for holes. Then find the attributes. Do not forget to check if the graph will cross the horizontal asymptote. Then create a sign chart, and then we're going to put it all together to come up with the graph. So we know that we need to factor the following completely first. If we factor the numerator completely, it's going to be factored as x plus 5 times x plus 2. And if we factor the denominator completely, let's say we wanted to do that. In this case, maybe try factoring by grouping. So we have x cubed minus x squared minus 25x plus 25. So we could make two groups, the first group containing x squared and x cubed, and the second group containing the other two terms. Within this first group, we know that we can factor out an x squared. So it'll be x squared times x minus 1. Within the second group, we know that we can factor out a negative 25, and so that would be negative 25 times x minus 1. We know that our outside factor would be x squared minus 25, and our inside factor would be x minus 1. Because x squared minus 25 is the difference of squares, we can factor it even further. So this will factor as x minus 5 and x plus 5. And we still have x minus 1. So our complete factorization would contain x minus 5 and x plus 5, as well as x minus 1 in the denominator. The purpose behind this is to check if there's any holes, or if there are any holes. We'll notice that x plus 5 is going to cancel out. That means that we'll have a hole for this particular factor. In other words, there's a hole at x plus 5, meaning that there's a hole where x is negative 5. So we'll find the y value by substituting it back into our remaining function. So if we take this negative 5 and put it back, we'll have negative 5 plus 2 over negative 5 minus 5 times negative 5 minus 1. In the numerator, negative 5 plus 2 will be a negative 3. In the denominator, negative 5 minus 5, that's going to be negative 10. And negative 5 minus 1, that's going to be negative 6. So if we multiply everything out, we have negative 3 over positive 60, which reduces to a negative 1 over 20. So negative 1 over 20. So let's find out what our other attributes are. So we already know that there's a hole at negative 5 comma negative 1 over 20. But what else can we find out? We need to find our x-intercept and also our y-intercept. Remember that for our x-intercept, for our rational function, we're going to concentrate on what makes the numerator 0. Remember that our numerator factors, or the x squared plus 7x plus 10, it factors as x plus 5 and x plus 2. So what would make this numerator equal 0? Well, negative 5 would make it equal 0, or also negative 2 would make it equal to 0. Except that we found out that negative 5 was a hole. So clearly we have to exclude negative 5. So that means that our x-intercept will only be at negative 2. So we're going to have an x-intercept at negative 2. So negative 2 comma 0. Let's say that we wanted to find our y-intercept. So for our y-intercept, remember that we're going to change all of the x's to 0. So it becomes 0 squared, 7 times 0, 0 to the third, 0 squared, 25 times 0. So basically, everything up here is going to be gone except for 10. And everything down here with an x is going to be gone. So that's just going to leave us with 25. So when we work everything out, our y-intercept is going to be at 0, comma, whatever 10 over 25 is. Now keep in mind that 10 over 25 reduces to 2/5. So our y-intercept is going to be at 0, comma, 2/5. Let's find our other values. Well, remember again that after we've simplified everything and canceled out that x plus 5, that what we had was x plus 2 over x minus 5 times x minus 1. Recall also that we said that the x-intercept was at -2, 0, and that our y-intercept, we just found out, our y-intercept is at 0, 2/5. Now let's work on finding our vertical and horizontal asymptote. For our vertical asymptote, we would look at the denominator and we would see what's going to make the denominator equal to 0. So we know that at x equals a positive 5 or at x equals a positive 1, our denominator would equal 0. So that's where we would have our vertical asymptotes. Our horizontal asymptote, we would need to use Bobo-Botten. So remember, Bobo-Botten eats DC. So we look at the exponents on the leading term. So our leading term here has a power of 2. Here it has a power of 3. So it's bigger on the bottom, which means that our horizontal asymptote is y equals 0. We need to check if we're going to cross our horizontal asymptote. So we'll cross our horizontal asymptote if our function is equal to 0. Basically, if this is equal to 0. So we would set our function equal to our horizontal asymptote to check if it crosses. And so we're going to set it equal to 0. So think about it. We have a fraction. When will a fraction equal 0? So if I have a fraction equal to 0, I know I can't put 0 down at the bottom. So it can be any number except for 0 down here. But I have to have 0 up here. So the numerator has to equal 0. In other words, x plus 2 has to equal 0. So that means that x is equal to -2. So it's going to cross right here where x is -2. The last thing that we need to do is to come up with a sign chart. So our sign chart should have our x-intercept as well as any vertical asymptotes. So we said our x-intercept was at -2. We are also going to put our vertical asymptotes. So our vertical asymptotes were at 1 and also 5. So we're going to choose test values. So let's say we pick -3 since it's to the left of -2. Suppose we pick 0. We could pick any number, but we're just going to pick numbers that exist on these intervals. So between 1 and 5, we can test out 2. To the right of 5, we can test out 6. It turns out if we put those numbers in for our x values, that if we put -3 in, we're going to end up with a negative value. If we put 0 in, we're going to end up with a positive value. For 2, if we put 2 in for all the x's, we'll end up with a negative value. And if we put 6 in for all the x's, we're going to end up with a positive value. So this is now enough for us to come up with our graph. First, let's put in the attributes. So we know that we'll have a point at -2, 0. We know that we'll also have a point at 0, 2/5. We know that we have a vertical asymptote at x equals 1. We have another vertical asymptote where x is 5. We know also that there's a horizontal asymptote at y equals 0, so that's just the x-axis. There's a horizontal asymptote here. And we know we're going to cross the horizontal asymptote at -2. So now let's use our sign chart. So according to our sign chart, we know that to the left, so here's one of our asymptotes of 1. So on the left-hand side of that, we're going to have a positive value. So here's 1. So to the left of that, we're going to have a positive value. And to the right of that, we're going to have a negative value. So just so there's no confusion, let me color this back in how it's supposed to be. So to the right and left of 1, those are our values. So let's say that we were to focus on the next asymptote, which is 5. So to the left of 5, right here, we have a negative value. So here's 5. So to the left of that, we're going to have a negative value. And to the right of that, we're going to have a positive value. So if we were to connect everything, we only cross at -2. So what's going to happen is we start off here. We know that's a part of our graph. We're going to meet our y-intercept. Then we're going to meet the next point, and we have to cross over on the other side. So we cross over, and then of course we have to stay close to our horizontal asymptote. If you notice, we're saying here that to the left of -2, so basically to the left of -2, that we're going to have a negative value. Notice that everything down here is negative. So we're saying also between -1 and -5, so between 1 and 5, we have negative values. So what we're going to end up doing is we're going up here somewhere and coming back down. Remember, this is just a sketch, so we don't know exactly how far up it goes. And of course, this piece here is a part of the graph. It's going to have to come down and connect with some other points down here. But notice that it doesn't cross because we said that it only crossed here at -2. So this is the only place that it crosses. So it's just going to keep getting closer, and there's our graph.